I want to focus on the 100 gig Lambda optics, which are, in my opinion, going to be the highest volume for all optics for the next 10 years. And the reason is simple. All the next generation switch chips use native 100 gig Serdes electrical I/O. And the 100 gig electrical Serdes works best with 100 gig Lambda optics, because anything else requires gearboxes, which add a significant amount of cost and power. And the volume expected for the 100 gig Serdes over the next 10 years is, according to certain market forecasts, is 1 billion lanes. So there's a lot of channels coming out that will need these optics. And
Andy, one question. Can you put the landscape?
Say again?
Can you put the landscape? We can now see the full. So the landscape. If
presentation mode.
Yeah, presentation mode.
Presentation mode. Is this better?
Yeah.
Yeah, much better.
Perfect.
Much better. Perfect.
And it works now?
Yeah.
Yep.
Thank you.
Okay.
Thank you.
So, and I have too many slides here, so I'm just going to skip over these. But basically, starting next year, we'll see the first 100 gig Serdes switch products coming to market. And the current expectation, based on this particular analyst from the 650 group, is that by 2023, the bandwidth of 100 gig Serdes shipments in the Ethernet switch chips will exceed the entire market next calendar year. So it's projected that the adoption of 100 gig will be very rapid on the Serdes side, and that this is the color in blue. And then maybe out in 24, 25, the 200 gig Serdes will show up in little green, but clearly the blue color here dominates for the next many, many years. Now, the 100 gig Serdes enables three new types of, it's not really new, enables upgrades to the established form factors. The SFP will be able to support 100 gig single lane performance, including 100 gig DR, ER, LR, SR. The 400 gig QSFP, not the DD, it's just a regular QSFP, 4 lanes, will support 400 gigabit and is fully compatible, of course, with the installed base of QSFP. And then the 800 gig form factors, the OSFP and the QSFP-DD, will support 8 lanes of 100 gig or 800 gig, which we believe will provide the highest density and the lowest cost. And this is the same chart here. But the kind of products we expect to see on the 100 gig side, on the SFP side, is BiDi optics, ER optics, LR optics, and so on. On the 400 gig QSFP modules, same selection: ER4, LR4, FR4, DR4, and even VCSELs. There are developments to deliver 100 gig capable VCSELs. So this is 100 gig Lambda VCSELs to the market next year with a reach of about 50 meters. And then on the 800 gig side, we expect to see everything from ER8 to FR8, LR8, dual FR4, dual LR4, and DR8 and SR8 in a single module. So clearly there's a whole spectrum of these optics technologies for different reaches and so on. But one thing to keep in mind, what matters to customers is optical interoperability. So for example, the first generation of 100 gig DR is available now in a QSFP form factor using a 4x25 to 100 gig gearbox. This, of course, is directly optically interoperable with the future second generation SFP 100 gig module that do not require gearbox because they connect directly from the 100 gig Lambda to the 100 gig Serdes. And also the 100 gig Lambda makes an excellent aggregation into the 400 gig DR4, which supports 4 lanes of 100 gig DR with the new SN or MDC connectors. Each of these would have an individual duplex fiber connection into the OSFP or DD module. The other thing I was going to mention here is that the 100 gig Lambda optics are in fact backwards compatible on the optical side if they are programmed to run at different speeds, because the wavelength spectrum is compatible. So the 400 gig FR4, if the switch supports the multi-speed capability, can be operated in a 100 gig CWM4 mode and directly talk to the install base of 100 gig CWM4 optics as well. So why 800 gig optics? The number one, and maybe the most important reason is just cost. The expectation is that 800 gig optics will be between 33 and 40% lower cost than two 400 gig optics that use the 8x50 gig interface. And this is because the 800 gig optics has a single DSP retimer chip, whereas the 400 gig optics, each one requires one of these chips, which is the most expensive part of the whole BOM cost. The second advantage is the system, the switch or the router is lower cost as well, because you get double the density, meaning smaller chassis, fewer connectors, fewer PC boards, and so on. And then most importantly, all of these 800 gig optics will be fully compatible with the initial 400 gig optics that are shipping today, because they also use 100 gig Lambda. And this is a chart from Intel that they showed earlier this year that talks about the cost reduction between 4 lanes and 8 lanes optics. And again, all the vendors we have talked to have confirmed there's a significant cost reduction expected. At the system side, a future 51.2 terabit switch with 64 800 gig modules that supports 128 400 gig ports fits into a 2U chassis, no co-packaged optics required. And some customers are really attached to their LC connectors for the LC patch cords. They have millions and millions of these installed in the hyperscale data centers. It turns out the OSFP can actually support a dual LC connector for the dual 400 gig FR4 in a single module option. So bottom line, and one more thing, in future silicon chips, there will also be 800 gig Ethernet, the native 800 gig MAC. Excuse me. So the 800 gig optics that will be starting ramping second half of next year will also be available by the time the 800 gig MAC starts shipping in 2023, which will be the first time in history that the optics will be available before the MAC. And the 800 gig Ethernet spec, I should mention, was already completed April this year by the Ethernet Technology Alliance. So in summary, 100 gig Lambda optics, it's not just to think about this, but to start deploying it. It's going to be the lowest cost per bit. It has the longest term lifetime of any optics, and it is backwards compatible in the various form factors, supports existing fiber connection and cables. And the simple conclusion is, 25 gig Lambda optics have served the industry tremendously well for the last 5 years. 10 millions of these optics installed. 100 gig Lambda will serve the same function for the next 10 years. Now, I have a few words on 400 gig CR, which is not 100 gig Lambda optics. Obviously, there's other presentations that will cover this in much more detail. But the most important thing to me is the element of IP over DWM, where you can load the 400 gig module directly into a switch or router and achieve the IP network over a native DWM network. The first version of this with 400 gig CR we had at Arista in January 2020, when we had the first OSFP modules, and we plugged them into a switch and they came right up, which was amazing. It took a little longer for all the vendors to talk to each other, but the history of IP over DWM, this concept has been around for many, many years, but traditionally there was a tremendous loss of density at the router level, where specialized DWM line cards were 70 to 90% less dense than the line cards facing the data center. And this was obviously not very attractive. With the pluggable 400 gig ZR and CR+, the industry finally got this right, which means there's a multi-vendor interoperable standard that allows the same density between the client optics and the data center, the DWM optics. And we do believe this will create an order of magnitude type cost reduction versus traditional solutions. The OEF did a survey earlier this year of what the attendees at this meeting thought how they would deploy it. Half the people responding said they will deploy IP over DWM. 12.5% said they will keep using dedicated transport boxes, and 37.5% will use both. Out of those people who plan to deploy 400 gig CR+, everybody wants to get the best FEC and the longest reach to improve the performance, of course. And just if it's not totally clear, there are multiple types of 400 gig ZR. The mainstream application is for the data center interconnect, 80 to 120 kilometers amplified. This is application code 0x01 on the module. There's also the gray optics version for 40 kilometer point-to-point non-amplified, application code 0x02, which competes with 400 gig ER4. That 0- module is not coherent. It's just a single wavelength. So it's really for point-to-point application without multiple wavelengths. And then, of course, there will be the ZR Plus, which will have a reach of up to 600 kilometer, maybe more on good fiber, based on the open ZR Plus standard. The summary here is the focus is to get the ZR into production. Samples are available now, should be shipping in volume in the first half of next year. And the second focus is the ZR Plus. There's some more validation work required, but it appears that the silicon is fully functional. And then the ZR- for the 40 kilometer case. 800 gig optics are being discussed. There's no spec yet, but several of the vendors are already working on the DSP design, targeting 16 QAM, double the baud rate, and a way to enable the same transceiver to be backwards compatible with 400 gig ZR. So these DSPs will be in 5 nanometer to reduce the power, and should also be the lowest power 400 gig ZR module at the same time. The focus here is on the 10 kilometer to 80 kilometer DCI kind of use case. Let me mention a few things on 200 gig Lambda. The previous speaker touched on this. So the initial focus is 800 gig FR4, 4 channels of 200 gig. The projection is this should be lower cost than 800 gig FR8, even though it needs a brand new optics ecosystem, which is still to be developed. However, one thing to keep in mind is that the 800 gig FR4 is really tied to the adoption of 800 gig Ethernet. The very, very first shipments of 800 gig Ethernet will be 2023, and it's not going to be the fastest ramp. We expect the 400 gig Ethernet to stay with the 100 gig Lambda Optics because of the installed base that's going to build to a very high volume by this time. And so far, nobody's asking for a 400 gig FR2 module, which would be 2 lambdas of 200 gig for 400 gig. Now, the other thing that will drive 200 gig Lambda Optics is 200 gig Serdes on the switch. The first switch chip with 102.4 terabit capacity with 200 gig Serdes is expected in 2024. And this will support 128 800 gig ports. However, even then, we do expect a lot of customers will use this 102.4 switch chip in a 400 gig mode to drive the networks that use 400 gig Ethernet. So 800 gig DR4, FR4 will be there, but will be linked to 800 gig Ethernet in my mind, whereas 400 gig Ethernet will most likely stay with the 100 gig Lambda for many more years. And I try to illustrate this in this graph. Now, the other question is, can 200 gig Serdes and 200 gig Lambda Optics fit into pluggable modules? We believe the answer is yes. The OSFP MSA started a working group focused on the 200 gig line electrical signaling question. This has been going on for a couple of months now, and we have very active participation with more than 40 attendees at every meeting. So this group is studying the interface challenges posed at this very high speed with respect to electrical bandwidth, mating interfaces, mechanical tolerances, and backwards compatibility. There's a lot more work to be done. The early data is promising. Basically, it's going to be quite challenging, but not impossible to achieve this. So in summary, 100 gig Lambda Optics are going to be very popular because all next generation switch silicon uses 100 gig Serdes, which is directly compatible with the Lambda Optics. There will be new speeds in the same form factors, 100 gig SFP, 400 gig QSFP, and 800 gig OSFP and QSFP-DD. And the 100 gig Lambda Optics will cover all reaches up to 40 kilometers with SR, DR, FR, LR, and ER. They're going to be very future-proof for the next 10 years. We expect, again, 1 billion 100 gig Serdes channels coming out of the switches in the next 10 years. They're backwards compatible if they're used in the multi-speed mode. And of course, they match the Serdes perfectly. 800 gig form factor, we believe, will be very popular. It achieves the high density and the lowest cost, both for the optics and the system. There's early work on 600 gig OSFP, as I mentioned, more work to be done. And then we do believe the OSFP offers the best thermal performance and signal integrity for both 800 gig and 600 gig optics. Bottom line, my key message here, it's time to start and think about the transition to the 100 gig Lambda Optics, which we expect will ramp very quickly next calendar year. And that's all my slides. Thank you very much.
Thank you, Andy. We got a lot of questions. So I think the first question regarding what next for 800G 1.6.
Wait, I didn't understand the question.
What next after 800G? You mentioned the 1.6T, 3.2T, or something else. So will 800G be the node for the industry?
Yeah, that's the simple reason is that people also need high radix on the switch chips. So switch chips with a radix of 128 ports have been very popular. And some people today deploy the 12.8 terabit switch with 128 100 gig ports, and then the 256 with 128 200 gig ports, and then the 51.2 with 128 400 gig ports. So you need the kind of radix per switch chip to have the connectivity required to build large networks. And if you just increase the port size even more, you get fewer ports, which isn't actually that helpful. So 800 gig will be the next major step, and it's going to take a long time for 600 gig native Ethernet ports. There's additional complications in implementing 600 gig in the silicon level in terms of just clock speeds are not increasing and so on. But the main thing is really how networks are being designed. And 400 gig is already more than enough for today, and 800 gig will address the needs in the next many, many years.
Okay, so the last question, Andy. So regarding 800G switch, how do you select the cage and connectors? A pretty specific question.
How do you select what?
The cage and also
cage?
the connectors, because you are using higher speed, right?
Well, we have tested OSFP at 800 gig, and it works very well. The QSFP-DD MSA also has an effort to write a spec that will work at 800 gig. So at this point, both OSFP and QSFP-DD should support the 800 gig, no problem.
Okay, thank you, Andy.